Hello everyone, this is Aditya and today we'll be solving some of the toughest integral problems for beginners. So let's start with the video, but before that please do like, share, subscribe my channel and be support video. Now let's start. So first of all, let's start with the easiest question of this video. The integral 0 to infinity of the quantity t raised to power n e to the power negative t dt. So if you have studied about gamma function, you must be knowing about this, right? So it is basically equal to gamma of n plus 1 or n factorial, right? So let's see how we can prove it. So solution. So integral 0 to infinity t raised to power n e to power negative t dt, right? So it is an exponential function and it is an algebraic function, right? And I should write n belongs to suppose positive integers or natural numbers, right? Okay. So this quantity, so it is a product of algebraic function and an exponential function, right? So let's use integral by part, integration by part. So let's assume this as the first function, this as the second function, right? So if you all know u dv, it is equal to what? It is equal to uv minus v du, right? This is integration by parts, right? So this is our first function, this is our second function. Here dv is equal to e raised to power negative t dt and u is equal to t raised to power n, right? So it is equal to t raised to power n. What is the integral of e raised to power negative t dt? It is equal to negative e raised to power negative t, right? And of course we will not be using any constant in this, right? So negative e raised to power negative t evaluated from 0 to infinity, correct? Okay. Minus the quantity integral 0 to infinity of the quantity. What is the derivative of since we need the derivative of u over here, so what is the derivative of t raised to power n? It is equal to nt raised to power n minus 1, correct? So we have nt n minus 1, and what is the integral of this? Well, of course it is equal to negative e raised to power negative t. So negative e raised to power negative t dt, correct? Right, so it is equal to negative t e raised to power negative t, or we can say upon e raised to power t 0 to infinity, and since we have a negative sign, so we can reverse the limits. So it is going from infinity to 0, correct? And minus minus will become plus integral 0 to infinity n t raised to power n minus 1 e raised to power negative t dt, correct? Okay. So now at 0 this expression will become 0, right? And at infinity this expression will become what? 0. Why? Because t raised to power n e raised to power n, right? Sorry, e raised to power t, right? Okay. So there are many ways to prove it, right? So if you apply L'Hospital rule also over here, then also you can prove that this expression is tending towards 0 over here, right? Or if you don't want, you can just use the infinite series also, 1 plus t square by 2 factorial and so on. So we know that there are infinite terms of t raised to power some number, right? So it means that it can be written as t raised to power n plus 1 plus t till t raised to power n divided by some n factorial plus some other infinite term. So of course this expression is greater than this expression. So of course it is tending towards it will tend toward 0, correct? Okay. So now we know that this expression is equal to 0, correct? Okay. Hence we have n integral 0 to infinity t raised to power n minus 1 e raised to power negative t dt, right? And what is this? Well, if I name it as suppose in, right? If I name it as in, this is n minus 1, right? So we can say that this is equal to n times n minus 1 times in minus 2, right? And so on, we can say n into n minus 1 till n minus 2, sorry, till 3 into 2 into I of 1, correct? Right? Right or wrong? Correct? Right. Okay. So now we have integral 0 to infinity t e to power negative t dt, right? Okay. So again, this is second function, this is first function. So we have t e raised to power negative t infinity to 0 plus the quantity 0 to infinity e raised to power negative t dt. Now we all know that this is equal to 1 and this is equal to 0, right? So you can prove it also. It is 0 to infinity e raised to power negative t dt. It is equal to negative e raised to power negative t evaluated from 0 to infinity. So at infinity its value is 0 and at 0 its value is 1. So since we have a negative sign over here, so we will get 1, right? So this is equal to 1. So this is equal to 1, right? So this is equal to n into n minus 1 till 3 into 2 into 1, so which is equal to n factorial. Hence this integral is equal to n factorial. That's it. Now let's move to the next problem. So now this is another problem. So let's see how we can solve it. Well, it is an integral. So let's see. So 0 to 1, 0 to 1, and so on till 0 to 1, x1, x2 till xn dx1, dx2, and so on till dxn, right? So there are n integrals over here. Right now, all of them are independent, right? Hence, we can just break this integral like this: 0 to 1, x1 dx1, 0 to 1, x2 dx2, so on till 0 to 1, xn minus 1 dxn minus 1 times 0 to 1 xn dxn, correct? We can say it like this. Now what is the integral of 0 to 1 x dx? Well, it is equal to x square by 2 from 0 to 1, which is equal to 1 by 2. Alright, okay, so we have 1 by 2 into 1 by 2 into 1 by 2 till 1 by 2 into 1 by 2. Now there are n 1 by 2 over here, so it is equal to 1 by 2 raised to power n, right? And that's the answer of this problem. Now let's move to the next problem. So let's solve this problem now. So we have a double integral in a region of the function e raised to power x square plus y square dx dy, where d is semicircle in first two quadrant, bounded by x square plus y square is equal to 9 and x is greater than 0. Okay, so let's see how we can solve it. Well, we can convert it to polar form, right? So we can say that x is equal to r cos theta and y is equal to r sin theta, right? We all know it. Okay, so if you are converting it to polar form, we must convert dx and dy also in terms of dr and d theta, right? So for that we will be using Jacobian of x comma y r comma theta, which is equal to del x by del r, del y by del r, del x by del theta, del y by del theta, right? So this determined what is the derivative of x with respect to r. It is equal to cos theta, and del y by del r, it is equal to sin theta, right? Okay, now what is the derivative of x with respect to theta? It is equal to negative r sin theta, correct? Okay, and what is the del y by del theta? It is equal to r cosine theta, right? So r cos theta, correct? Okay, so it is equal to r cos square theta plus r sin square theta, which is equal to r, right? So we have this region, e x square plus y square dx dy is equal to e raised to what is x square plus y square? Well, it is equal to r square cos square theta plus r square sin square theta, which is equal to r square. E raised to power r square r dr d theta. Now what will be the region? Well, of course, x square plus y square is equal to 9. Hence, the radius is equal to 3. So it is equal to 0 to 3, correct? And what is the angle? Since we want in first two quadrant, so the angle will be from negative pi by 2 to pi by 2, correct? Okay, hence now since there is no theta over here, so we can directly say integral d theta negative pi by 2 to pi by 2 of the quantity, I mean multiplied by the quantity 0 to 3 r e r square dr, right? Now this is equal to pi, simply pi. Okay, now this integral, well, we all know how to solve it. Integral 0 to 3 r e raised to power r square dr, correct? Now you can solve it directly also, or you can just use r square is equal to t, or instead of t, have we used t over here? No. So r square is equal to t, so 2r dr is equal to dt, or we can say that r dr is equal to dt by 2, right? So when r is equal to 0, t is equal to 0, and when r is equal to 3, t is equal to 9, right? So we have this expression 0 to 9 of the quantity, what is over here? We have e raised to the power t times the quantity dt by 2, correct? We have this expression. So it is equal to e raised to power t by 2 evaluated from 0 to 9, which is equal to e raised to the power 9 minus 1 divided by 2. So we have pi times e raised to the power 9 minus 1 divided by 2, and that's the answer, right? Okay, so now we have this problem: volume for intersection of ellipsoid x square plus 2y square plus 2z square less than equal to 10 and cylinder y square plus z square is less than equal to 1, right? So over here we will be using something called the cylindrical coordinates. Okay, so we will assume over here that y is equal to r cos theta, whereas doing the polar form over here we will be using the cylinder point form over here, right? And z is equal to cylinder coordinates, basically we are using over here. Z is equal to r sin theta and x is equal to x. Since there is no x over here, so that is why I am assuming this one, x over here like this. Okay. So now let's calculate Jacobian of x, y, z, x, r, theta, right? Because we have to convert it from this to that region. That is, we need to calculate this area, this volume in the region dv, right? Okay. So we have to convert it in terms of dx, d theta, and dr, right? Okay. So this is equal to del x by del x, del y by del x, del z by del x, right? And over here we will have del x divided by del r, del y by del r, del z by del r, and over here del x by del theta, del y by del theta, del z by del theta, right? Okay. So this is equal to 1 0 0, and what is del x by del r? It is equal to 0. Yeah, it is equal to 0. And what is del y by del r? It is equal to cos theta, and this is equal to sin theta, right? This is again equal to 0. And what is del y by del theta? It is equal to negative r sin theta, and what is del z by del theta? It is equal to r cosine theta, r cos theta, right? So of course this will be equal to r cos square theta plus r sin square theta, which is equal to r. Okay. So this is equal to integral r dr dx d theta, right? Okay. So now what we can do? Well, we have to first of all, now we have to substitute the limits over here, right? So we all know that it is an ellipsoid, so we want to calculate it in the whole region, right? So it will going from 0 to 2 pi, correct? And x, well, we have to calculate for x over here, so just wait. Dr, we all know that this is the value, this is r square less than equal to 1, right? So it is going from 0 to 1, correct? Okay. And the next thing which we have to notice over here is that what is dx? Well, dx is going from this region, x square plus 2y square plus 2z square less than equal to 10, right? Okay. So x square plus 2 times what is y square plus z square? It is equal to r square, right? So r square, this quantity, correct? Okay. So x is less than 10 minus 2r square, right? Hence x is lying from negative 10, or I can say negative root 10 minus 2r square to positive root 10 minus 2r square, correct? Okay. So we have to just substitute the value over here. So we have negative root 10 minus 2r square to the 10 minus 2r square, correct? Now we have to just evaluate this region. Let's see how we can evaluate. So of course there is no theta, so we can directly open this. So we will have 2 pi over here times now this integral. Well, integral of so first of all, what we have to do, we have to evaluate this integral. So let's see how we can evaluate it, right? So we all can see that if we evaluate it like this, then there's some problem. So we can clearly see over here that here should be dx and here we should keep dr. Okay. So I can just change it like this. It going from negative root 10 minus 2r square to root 10 minus 2r square, right? 10 minus 2r square, correct? And over here it is going from 0 to 1, okay? 0 to 1, and r can be brought over here, right? Okay. Now let's evaluate this. So it will be 0 to 1 r times the quantity. When I will evaluate this, it will be 4 over here, and 10 minus 2r square dr, right? Now let's evaluate this. Let me erase this one. So when we will erase this, I mean after erasing this, we'll solve it. Okay. So yeah. So here we have 4 pi times the quantity 0 to 1 r root 10 minus 2r square dr. Now it is a very simple integral if you can observe it. 10 minus 2r square, let's assume it as t. So we have dt is equal to negative 4 r dr, correct? So we can clearly see that this is equal to negative 4 dt by negative 4 r dr, right? So 4 pi times the quantity, when r is equal to 0, t is equal to 10, right? When r is equal to 1, t is equal to 8, right? Okay. So it is square root of t dt by -4, right? Okay, so let's evaluate this one. Yeah, so what we are getting, we will get negative pi over here, and over here t raised to power 3 by 2 into 3 by 2 evaluated from 10 to 8. Now we can remove this negative sign. We will have the limits going from 8 to 10. So this is equal to 2 pi by 3, 10 raised to power 3 by 2 minus 8 raised to power 3 by 2, right? Okay, so you can either further simplify it. You will get over here 10 root 10 minus 8 root 8, right? And that's the answer. So this was a nice question. Now let's move to the next question. So this is the last question. So we are given this contour integral of the function e to the power z divided by z plus 1 whole square z minus 2 dz, where c is such region such that it contains the points -1 and 2. So basically these points are lying inside it, right? So basically they are non-analytic. So this function is non-analytic at -1 and 2. So we will apply Cauchy integral theorem, right? So what we'll get? Well, if you don't remember, Cauchy integral theorem is basically f of z divided z minus a dz is equal to 2 pi iota f at z, right? Sorry, f at a. And if I write its differential form, it is this: f of z minus a raised to power n plus 1 dz is equal to 2 pi, this is 2 pi iota divided n factorial nth derivative at a, right? So you can check out my complex analysis video in that, complex integral video. In that I've already covered all these things, so you can check that. Okay, so now let's evaluate this. So this is the integral e raised to power z plus 1 whole square z minus 2 dz, right? Now of course it is a simple integral. If we can clearly see the pattern over here, if you can see the pattern over here, because we have to just use partial fractions over here. So let's see how we can do it. So 1 upon z plus 1 whole square z minus 2, let's break it using partial fractions. So it is a upon z minus z plus 1 plus b upon z plus 1 whole square plus c upon z minus 2, right? So just multiply this over here, over there. So a times z plus 1 z minus 2 plus b times z minus 2 plus c times z plus 1 whole square, right? So let's substitute z is equal to -1. So when you substitute -1, this will become 0 and this will become 0. So we will be getting b times -3 is equal to 1. So we get b is equal to -1 upon 3, right? So we have b is equal to -1 by 3. Okay. So now let's substitute z as 2. So we will have this expression will become 0. This will become 0. And c will be equal to 1 upon 9, right? So c is equal to 1 upon 9. Now what value can you substitute? Well, let's substitute z is equal to 3. Okay. So if z is equal to 3, we have 1 is equal to a times the quantity 3 plus 1 4 into 1 plus b times 1 plus c times 4 3 plus 1, it is equal to 16, correct? Okay. So 1 is equal to 4a -1 by 3 plus 16 by 9, right? Okay. So let's take the LCM. So we have 1 plus 4a minus the quantity, or we can say plus over here, -3 plus 16 divided by 9, correct? Okay. So we have 1 is equal to 4a plus 16, sorry, plus 13 by 9. So we have over here 4a is equal to 1 minus 13 by 9, which is equal to -4 by 9. Hence a is equal to -1 upon 9. So a is equal to -1 upon 9, right? Okay. So let me erase this. So we have taken the partial fraction over here. So what we have got? We have got a is equal to -1 by 9. So -1 upon, we can say it like this: -1 upon 9 divided z plus 1 plus or we can say plus, yeah, -1 upon 3 z plus 1 whole square plus 1 upon 9 z minus 2, right? Correct. So now we can just write this as e to the power z plus 1 whole square z minus 2 dz is equal to the quantity, this integral e to the power z plus 1 -1 upon 9 plus, or we can say minus dz, of course, minus 1 upon 3 e to the power z plus 1 whole square dz plus 1 upon 9 integral e to the power z z minus 2 dz, correct? So this is equal to what? Negative 1 upon 9 into 2 pi iota function at a, that is function at negative 1. So e to the power negative 1, correct? Okay. Minus 1 by 3, 2 pi iota, this one, over here n is equal to 1, correct? This is a. So n is equal to 1, so we will have 2 pi iota divided by 1 factorial, that is 1, into what is f of z over here? E to the power z, correct? So f dash of z is equal to e to the power z again. So at a it will be equal to again what? E to the power negative 1, correct? Okay. So where we have a plus sign, let me write it. Okay. Plus 1 upon 9 times the quantity 2 pi iota times the function at 2, that is e square, correct? Okay. So now let's just evaluate this. We'll be getting, let's take 1 by 9 common. 2 pi iota divided by 9, let's take it common. And since we have two negative sign, we can take a negative sign also common. So we will have this plus 3 times e to the power negative 1 plus e square. So we have this expression is equal to a negative over here. This is equal to negative 2 pi iota divided by 9 times the quantity 4 e raised to the negative 1 plus minus e square. So it is equal to 2 pi iota divided by 9 e square minus 4 upon e, right? And that's the final answer. So I hope you enjoyed this video. If you did, then please do like, share, subscribe my channel and please support this video. And yeah, I have already made a one-shot playlist for complete engineering mathematics, so you can check out that video. And I am now trying to make masters mathematics too, so please stay tuned, please subscribe this channel. Bye bye, take care.